Good morning, Jean-Marc.
Good morning, Laurent.
Today I would like you to present a use case about optimizing a progress report of a big engineering project.
Yeah, sure. The first example we could talk about is what we did with the shipyard to tackle issues around the progress report for electrical engineering. So, to talk about it very simply, the fact that when you build a ship, you have tons of electrical equipment and electrical wires, and of course it takes time to build all of that on the ship. And progress report is the fact that you can have a sense of progress of all this installation of electrical equipment. So being able to know what equipment has been actually wired or not, whether it's actually connected to the network, whether it's working or not, and so on.
What do you think are the main issues around progress report in that kind of big engineering project?
There are several issues. The first one would be that the notion of progress is just not something as simple as on or off. Even in electricity, you might think it's on off, and it's more complex than that. There are multiple stages of progress, and you want to make sure that in your digital twin you can actually very easily see that sense of progress. So when you have the digital twin, you can know based on colors, for example, what is the actual progress of each equipment or each wire. So this notion of progress has to translate in the twin itself, visually in a very instinctive manner. Then the other issue is that when you are building such a big project, you are off-site, so you're not in an office. So there is a question of mobility. You need to be able to see all this information quickly and to be able to add new information to it, to change the progress of an equipment, for example. You need to do that in mobility using a tablet or smartphone. So it has to be very, very efficient. And mobility also implies that maybe you don't have an internet connection. Okay, you're building something, you're building electricity. So basically you have no Wi-Fi on the ship because you don't even have electricity. So you need to be able to work offline, and that's also a big challenge.
Before you worked with this shipyard, what was the solution in place?
So what they had is they customized an existing 3D viewer, and they added features to it to be able to add this progress attribute to each object. And so they were able to go on the ship with a Windows tablet, so an actual tablet PC on the ship, on site. And they were using this customized solution to edit the progress of each equipment in real time. But everything was happening on the tablet PC. So to report the actual progress, they had to go off-site. They had to export some spreadsheets for each blueprint and then upload those spreadsheets to a database. And so obviously there are key major problems with that. The first one is that if you just forget to export the data, it never goes back to the database. So for example, you go in a holiday for a few days, your work is lost on some computer somewhere. And eventually someone will redo the same work because they have no idea you've done it. So there is some kind of a wall between what we've actually done on site and what's actually in the database. Okay, that's like a disconnection, and that's not good. You do rework a lot. The other issue is, of course, that you're working on a tablet PC, you have only a few hours of autonomy. So when you have to work a full day, you need to go back to the office, plug it, wait to have some battery, and go back on site. So the device itself was not really good for a full day of work. The way it works for them is that every morning they would sync down every blueprint, every digital twin they need. They will sync them down on their tablet. So it's completely offline. You have all the features you have in SmartShape, all the features you use when you're online, they are all embedded on your device. You can go on site and you have absolutely no internet connection whatsoever. You can still set the progress of each equipment, okay, according to the work you're actually doing and the verifications you're doing on site. And then when you go back in your office, for example, and you have a connection again, you can just sync up your changes. And all your changes will be synced to the cloud and database. So this issue of having to export files and re-import them back with a manual workflow, it's not here anymore. Everything is automated. You just press a button to sync down, press a button to sync up. Okay, very, very easily. And the technical issue about mobility, well, there is of course this offline capability, and it works on an Android tablet, okay, a consumer-grade Android tablet. So you have a great autonomy, great battery life, and the application, the SmartShape application, is really optimized to have the best autonomy on those devices. So you can work a full day, and then at the end of the day, you can just press a button to have your reports automatically sent to the database. And you don't have to worry about having a huge, big tablet PC, which is heavy and which is not very practical to use.
What are the actual key benefits that the shipyard has experienced with SmartShape?
The main key benefit is the fact that the workflow is driven by the platform, and they have eliminated human errors. The simple fact that you've made some work, and because you just forget about synchronizing stuff by exporting files and re-importing them manually, it can cause a lot of delay and a lot of errors. So the first key benefit is the fact that now you just have to push a button and it does all the work for you. And so we're also targeting to improve that so that you don't even have to push a button. So in the future, we'll detect that you have access to network and push things automatically. So it will be even more improved. Okay, no manual action, because when you have a big engineering projects, there's so many things to care about, so many equipments, so many blueprints, so many digital twins to deal with. You want something which is as simple and as automated as possible. So the key benefit is also that what they have in the database is up to date in real time compared to what's happening for real on site in the ship itself. So it's an actual digital twin because the connection between the two is as close as possible to real time. You have to remember that on this database that stores the progress, you probably have other applications that are connected to it. Let's say that you have wired something, for example. Well, you might have a workflow that will say when that cable is connected, is wired in, I need to do this task, for example. And all those applications connected to the same source, to the same digital twin, they can be updated and triggered in real time.
Okay. What are the other areas where this progress report feature could be applied?
So with the same customer, we're talking about using the exact same methodology, workflow, and tools in SmartShape to do progress on other parts of the ship. So it could be piping, it could be structural engineering, it could be basically anything. Behind progress, it's mainly the time thing, the dimension of time. So anything that will need to evolve through time with a more or less complex information about that timing and that phasing. The same would apply to it, and not just in shipbuilding, but also when you're building an actual office or a power plant or anything like that. The dimension of progress, it exists in all those projects in a different way, but they face the same problem.